Oh, yeah, Kirk, can you hear me? Okay.
Yeah, I can hear you. Hey, David, how are you?
Oh, doing well. I just had a student visiting the lab, so
Oh, I see. Okay, yeah, sorry. I mean, I don't know. Like I sent this invite to you and Ramki, both of you. He saw the invite. I don't know for some reason. Maybe it's not showing up on your calendar.
yeah, sometimes I'll get it as an email, but I'll be upfront. I get like 200 to 400 emails sometimes, especially now because I'm getting all the students Git commits across dozens of projects. So unless it's in a specific format, it doesn't show up in the calendar itself. Then there's a 1 in 10 chance I may see it, but it has to
Okay.
be in a specific format. And sometimes if it's through like a Gmail or other styles, it still has the textual content, but it doesn't automatically get inserted into my calendar regardless of whether I click accept or not. So I apologize for that.
Oh, okay. No, no, no worries. Yeah. So I also just want to confirm, I sent this invite for you. If this is your email address, davidl@illinois.edu.
Correct. Correct. Yep.
This is correct. Okay. And just want to make sure, from December 5th onwards, we also have that bi-weekly sync up for this project.
Yep.
So do you have that one on your calendar? Just want to make sure.
Let me check it. So this starts on the 5th.
Yeah, and then runs every 2 weeks. Of course, we can cancel when, it's a holiday or something, but yeah, just
Sorry, I have to click on it manually. It keeps scrolling me back up.
yeah, no problem.
No, I don't have that on my menu at all. And I have two appointments both at 9 a.m. on December 5th, but then nothing else is showing up.
Oh, really? Okay, let
Yeah.
me see. Okay.
Yeah, it's probably because it's getting sent. So what Outlook does is really annoying. They send it as the Outlook style, so or sorry, as the Gmail style. And so they embed in it, I think, a what is it, ICS or similar, but it doesn't, at least Outlook won't automatically take that and put it on people's calendar. It's really annoying. They intentionally make these things not cross compatible, I assume, to get sort of network
Yeah.
effects and vendor lock in.
Do you see the email? Can you search for it?
I can search for it. I was trying actually from my phone, and when I searched from Anchor, nothing was pulling up, but that may only be limited amount of. Okay, so I
Okay.
see the initial email. I see the Google Drive share. Did this go to spam, maybe?
This should be the title. It says biweekly sync up POC, something like that. You can search with that
Yeah, I'll search for
straight.
time sake. That probably. But yeah, it looks like that went out as a Gmail style one.
Yeah, because this is a Gmail account. So
Yeah.
all the OCP accounts are on Gmail,
Yep.
unfortunately.
It's so I don't have that calendar, but I'm having trouble finding the email too. I see other ones you had sent that was sort of text based, but all I'm
Uh,
seeing is the email from 11/14. And
how
then
do I?
when did you send it out?
This was sent. Let's see.
Because I do vaguely remember seeing it, but that's why I'm surprised I don't see it at all in my inbox, unless again it got junk or.
This is weird. This is my sent email. This I saw this reply should be somewhere.
Okay, I did find it. That one I never did see. It did get auto classified as junk.
Oh, do you see the email with the biweekly sync up?
Yeah, I found it only in my junk box on Outlook 365.
Oh, okay, perfect. Okay.
It's not
Yeah, because
junk.
like I see people have accepted this meeting, so I'm sure the invite was sent.
Yep.
Uh
No,
yeah.
no, it definitely did go out. It was hidden because of that.
Okay. Yeah, if you can accept the whole series, that'll be great. At least it will show up on your calendar then.
Perfect. Yeah, that's what's annoying is they include the ICS, but they send it Google format.
Yeah, I run into those issues a lot of times,
Oh,
definitely. Our
it's
our
constantly
company
my
does.
life with my students. So the thing that drives me even more nuts is if students use at least our Outlook,
Yeah.
not only does it do all this, it auto generates a Teams meeting even when I'm giving it a Zoom address. And so then sometimes my students, I have to tell them, and they mess it up with like a 50% probability. The
Hmm.
location is the proper Zoom room, but then there's a Microsoft Teams room that Outlook auto generates and inserts. And then half the
Okay.
people will be on one, half will be on the other. And it's just, all this drives me nuts. It's we don't enforce antitrust. What can you say? I didn't say that, but all right. So
The,
so
the,
now it's added. I think I see it. Let me check just to validate. Perfect. Yeah, noon p.m. bi-week. Just to confirm, that's supposed to be noon p.m. Chicago time, 1 p.m. Eastern.
Noon PM Chicago. Oh wait, no, this is 10 a.m. to 11 a.m. Pacific, which will be
Yeah,
East.
noon.
You're on East Coast, right?
I'm in Chicago.
Chicago, so that's East Coast. So,
Oh, Chicago's Central
oh,
Time.
Central. Yeah, so that's noon. Yes, that's
Okay,
right.
perfect. All right, we're good then. Yep.
Perfect. Awesome. Sounds great. I'll be looking forward to, seeing you on those calls because you're the main person helping us on this. Of course, I don't want to miss out on you for sure.
No, I'm,
So,
I'm happy to help. This is something I've actually considered doing, also just for other cases, like
yeah,
how tightly can you coordinate machines? And one of the
right,
other
right.
contexts where it gets useful is like when you have a hot primary and then a warm backup. To
Hmm.
what extent, cycle for cycle, can you keep them in sync if you apply all the standard HFT tricks to really
Right.
lock down the machine? For example, you basically completely remove the Linux kernel from one of the two packages or
Hmm.
sockets of a dual socket system. And then
Got it.
if the network card is directly wired to that one, you can keep the cache lines pretty pristine and then see how what the distribution of reaction times are. So that's perfect.
Right.
So, but I apologize, I missed this one.
No, no,
Again,
no,
it
you're
may have
good. All
been.
good.
So,
Yeah.
what is it you'd like to talk about?
Yeah, so I just wanted to, sync up. Actually, I saw the email thread between, yeah, this is the one I was referring to. You can see my screen, right?
Yep, perfect.
Okay,
Yeah,
so
I was going
I
back and forth
saw,
with Romkey, right?
yeah, so I actually, I was looking at it and I thought, like, we are asking, correct me if I'm wrong, like, I understood that you're looking for White Rabbit devices from, is that what you're looking from Saffron side or?
No, I don't want White Rabbit because I don't have the gear that would sync to White Rabbit other than the primary. So I'll show you my current setup.
Yeah,
I just need
that's
to.
what I was going to move to. Like, I wanted to check what do you have right now, and that
Yeah, yeah.
way I was
So, so
talking to Ramki that we
and let me
can.
just send one message first. I have to push this student back
Sure, yeah.
because this is worthwhile doing. Let's let it 4 p.m. All right. So background and effects off. And then some of this I may switch to my Bluetooth headset. So in terms of the setup for TimeSync itself, so this is basically like an open source one I have students building,
Mm-hmm.
but it's basically the internals of what most of these have. So we have an EVK F9T. This is pretty much one of the more bleeding edge GPS receivers.
Okay.
The F9T, the advantage of it, if I understand, if I remember correctly, it's the first chip from U-Blocks that does dual frequency. And the reason that's important is this allows you for to correct the changes of the speed of light that change as a function of the ionosphere. So the speed of
Okay.
light, even through air, is not constant. It depends on things like the weather. And so because this simultaneously listens to both what's called the L1, which is the historical
Mm-hmm.
civilian band, L2 is the military. They do versions of this that do that, not this one.
Mm-hmm.
But the new one they added in recent satellites that they keep adding more of is L5. And so if you have L1 and L5, it can use that for doing the ionospheric correction.
I
So this
see.
is
Okay.
supposed to be like, well, but a lot of the vendors, if you open them up, they very often have, they're not going to have this whole box. This is the dev kit,
Okay.
but they'll have the
Okay.
F9T chip inside. And so
Okay.
what this does is on one side, you can see here, this is the RFN. Some of the antennas are right there by the windowsill. But the two main things you want is one, you get a USB that's really just like a serial port, and
Mm-hmm.
that's blasting out a lot of the metadata it's getting. And there's different formats for that. I think it's like
Mm-hmm.
NMEA is the industry
Yeah.
standard, and then you get U-Block specific. And
Mm-hmm.
then you have this, which is very important. This is your pulse per second out.
Okay. PBS.
Okay.
Yeah. Okay.
Then at sort of the center of the app for command and control, I have a Raspberry Pi CM4. The
Mm-hmm.
reason you want to use the CM4 in particular is I think it's the only Raspberry Pi that has hardware support for PDP
Oh, wow. Okay. Yeah,
directly.
that's true.
So both the Raspberry Pi 5, the Raspberry Pi CM5, and the Raspberry Pi 4 regular and down, they don't have the same Mac. So that's advantageous. There are ways around
Wait,
that though. Go
David,
ahead.
what is the Raspberry Pi type that you're using right now, which has the PDP support?
So
Can
the
you?
only one that I understand that has full support in the external Mac itself is the Raspberry Pi CM4. So that's the compute module form factor variant of the Raspberry Pi 4 generation.
I see. Okay.
From what I understand, and you can ask Ahmed and his connections at Broadcom, but
Mm,
based on at least what's in the public domain, when they did the fifth one, they're no longer doing it the same way. And so, like on the
mm-hmm.
Raspberry Pi 5 itself, they try to do it in this weird in between. So you have the
Mm.
Raspberry Pi chip itself, then they have another chip, and I'm going from memory, so take this with a grain of salt. But I think it's like
Sure.
the RP1 is sort of like what I would call a Northbridge if this were traditional computing.
Okay.
And so normally that's sitting there. And I think that's where they're trying to apply the timestamp. But anytime
Mm,
you add extra hops, and this is not their bread and butter. So did they do it really perfectly right? And who's, monitored it? Where if you just have an IP core that was explicitly designed, I think
mm,
it's one of the major, what is it, Synopsys or Cadence IP blocks. I'm guessing they threw down.
mm.
Well, I didn't check because it's Broadcom for them, but so that's sort
Got
of
it.
the brains. But really, for a lot of this, you almost don't even have to look at that. That's really just how you do command and control. But what I
Okay.
also then have on top here is a scientific grade large rubidium atomic clock. And so the
Okay.
way this works is this generates 10 megahertz, but it also has special firmware for taking the pulse per second out going
Okay.
into here. And so if you were to try to know to exactly the nearest second, oh, let's say between now and a year from now, you want to rely on this. If you
Mm,
literally want to say, tell me when it's been a billion nanoseconds since
mm-hmm.
the last round second, you want to use the rubidium. And so the
Okay.
key typically is you combine the two to get better short-term and long-term stability. So
Okay.
allegedly, this will stabilize things out. This was actually looking at a device that did not have this, or at least
Okay.
wasn't conditioning this. This is
Mm,
what first set me down this rabbit hole of time sync, looking way
mm,
more detail. Because what
mm-hmm.
I'd see is doing PDP sync with a lot of machines at
Mm,
a firm you could guess, but I won't mention because this recording may be public.
mm,
And I saw literally dozens of machines doing PDP sync to one of these atomic clocks, then over Ethernet, or not atomic clocks, one of these
mm,
GPS receivers, then over Ethernet. And they would
mm,
all be off, but they would all be
mm.
off by the exact same amount. And I was like,
Got it.
that's odd. And then
Mm,
that's what I learned that there's a lot amount of jitter on these. They can be anywhere
mm,
from like plus to minus 5 nanos, and that's sometimes what they quote, but sometimes it's much, much worse than that. And so if you take two of these, run them side by side, depending
mm,
on the environment you're in, you then hook them up to an oscilloscope and look at the deltas. And when I was doing this, I was seeing like plus or minus sometimes 100 nanos drift over the
mm,
day just between two GPS grandmasters. And so that's where the
mm.
hope is this will smooth it out. Then the other thing I have, in full disclosure, they're a competitor to, I think the major competitor now
Okay.
to Saffron, although this isn't sensitive IP. This is just a pulse per second repeater. And so
Okay.
what this does is you do the pulse per second out of here, it goes into this. This way
Mm-hmm.
you can take one signal and then send it to end machines. For example, if we
Okay.
wanted to use this to do a pulse per second in for the 5 machines we're talking about in your setup.
I see.
And
Okay.
so you could either feed them directly from this and or you could send packets over Ethernet. We'll have to
Mm.
double check. Well, I guess we could drop it down to 1 gig. I remember there's this edge case in PDP that it doesn't like it when you have uh,
Okay.
changes in speed lanes. So it's like if you have basically if you asymmetric latencies of a 1 gig going one way and a 10 gig going the other. But the
Mm.
other way we could do that is just have a dedicated Ethernet port on the high end NICs
Mm.
and then drop that into 1 gig and do the same thing on the switch port. So now we get into the network cards themselves. And this
Mm-hmm.
I have to check. This is either an X2 or the 800 series. But I basically have, in many cases, two of each, in some cases more. But this is a solar flare card. So this is sort of the de
Oh,
facto
okay. Yeah.
standard for x86 trading.
Mm.
This generation has two SFP plus 10 gig ports. I think this generation can also do 1 gig, though I have
Mm-hmm.
to double check. I know at some generations they did not support dropping down to 1 gig, or it may have just
Okay.
been they don't support auto negotiation. You have to manually
Mm-hmm.
flag it. But the
Okay.
other thing you can see if you look at this very closely, and I'm trying to see what you see to get it. I
Mm.
forget the terminal point, but this is like a baby coax connector. I forget what these are called. I hate these personally, but this is how
Okay.
you can add pulse per
Mm.
second in and or pulse per second out. And so what you
Okay.
do is you attach a little dongle, you feed the cable through here, and then you can have it just hanging on the front. And some of the
Okay.
cards I have already have that directly hanging out, depending on the
Got it.
generation. But that's how, if you wanted to skip going over the network and just take the signals
Mm.
directly, you
From
could.
PPS. Yeah. Okay.
Because historically, there's a known problem, and I forget if it's on the exact same network port or even if it's on a different network port, if it's just on the same NIC and computer, that as the
Mm.
packet load gets closer and closer to 100%, the
Mm.
PDP numbers don't look good. And the vendors were very open on that. I think it still may be in the public domain. They go
Right.
through and show, and then it gets messy. And especially doing AI, some of the work
Mm.
cases are saturating the network, depending on how you're getting data into the GPUs.
Got it.
So
Got it.
those are things to be aware of. Then in terms of the rest of the stuff, I can just show you behind me. Give me a
Mhm.
sec so you can see. So
One
behind,
quick question, David. The solar flare card, do you have the model number for this one? And does it also support PDP? Does it
they
have
all
a P?
support PDP starting with
Okay.
Gen 6, which I don't think I have, but I have, I want to say five 7X series solar flare cards, two 88X series, two X2 cards, and two X3 cards. And now the latest, though, they haven't sent them to me yet, are the X4s, which were just announced like a month and a half ago.
Okay.
But this is pretty common for your setup.
Hmm.
The other thing I do have a few of, and this is really just if you wanted to throw it in the Raspberry Pi.
Hmm.
This one actually Ahmed gave me. This is the time card. So there's
Oh,
this
okay.
one type of Intel chip, 1 gig, that also
Hmm.
supports PDP and pulse per second. And so I bought a few different cards off Amazon that also
Hmm.
have that chip. And then the thing I like about this is it directly has the coax SMA connectors on it. Some of the
Hmm.
other boards, you have to like wire it up to individual pins and toggle some random
Okay.
flag in the firmware. But if I
Okay.
remember correctly, these are based on some sort of Intel 2 something chipset.
Got
I'm
it.
trying to read it,
Okay.
but the numbers are too small. And I can get you those details. But I do have these as well.
Yeah.
But
Okay.
again, for me, I generally lean on the simple of
Yeah.
just pulse per second. When you run
Yeah.
a
No,
coax cable and you make sure they're the same length.
makes sense.
Again,
Totally.
it'd
Yeah.
be fun to compare the two too. Because I mean, I can see, depending on how you configure it, especially if you're very aggressive on 10 gig on constantly sending out a continuous stream of timing updates, and it's on a pristine dedicated network, then I could see other cases where you do get very good results. But
Mm.
it's just anytime you have many vendors in the space and playing with each other, and then also the more knobs you have, the more likely someone is to screw it up. It's hard
Makes
to,
sense.
coax I like because I view it as the equivalent of like plug the computer into the wall. Does the
Mm.
light come on? It's
Yeah.
like it works or it doesn't. You typically don't. I'm being a little overly simplistic, but normally you're not manually configuring. Oh, is it 60 hertz or 61 hertz that I want coming out of the wall? You don't have a choice. You
Right.
just plug it in, and it either works or it doesn't. So,
Right. 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 No, this is great. Thank you, David, for showing me what you have. So
yep.
it seems like you already have the setup for PPS connectivity. So
PPS and PDP. The only
PDP.
question
Okay.
was, it seems like Saffron wanted to be in the mix. So if instead of using that, they want to use theirs as a GPS Grandmaster, I'm fine to do that. Like I'm not going to
Oh,
fight it. It'd
okay.
be fun to try out. But the extent is not to do White Rabbit. I don't know that any of the FPGAs actually. So we
Their
may want
white
to.
their White Rabbit boxes do have white, and they also have a White Rabbit fan out device. So, but I think that will be an overkill. I think if you, like you said, if you want to keep it simple, we can check with Ramki. But I guess your
Yeah.
setup looks good to me, actually.
I mean,
Yeah.
I have the base. It's just I assume that he showed up in the meeting. I think he wants their company involved. So I'd be
Okay.
happy to have their production grade device. We can try it.
Hmm.
The other major one that I have connections with, we could talk to is Time Beat. So they're the one who provided that repeater,
Oh,
but they
okay.
also have a direct competitor.
Hmm.
They're, from what I understand, the closest thing to the primary competitor now to Saffron with White Rabbit. I think
Got it.
just in the last month or two, they're the second one to do it. But typically, when you see White Rabbit, it's going from a GPS Grandmaster over
Hmm.
fiber to another rack. But then there may be some cards that do support it. But normally, I think of that as more you bring it to top of rack, and then you're
Mm.
going back again to coax and or PDP.
Got it. Okay. Yeah.
Right. Now, I'd have to check. I wouldn't be surprised if some of the vendors have added White Rabbit support. I know there are IP cores. I haven't heard of Solar Flare implementing that yet.
Hmm. No, I
Um,
don't. I don't. I don't think so. That's why I was going to. I was asking you what card you're using for Solar
Yeah,
Flare.
so
Okay.
I have all the different solar flare cards. The other one I would talk to, I think his name is Seth Friedman. He's one of the co-founders of, I
Hmm.
think it's Liquid Markets. They have an Altera base, and I think also, well, some of this is recorded, so to be careful what. I'm
Yeah.
not under NDA, but it's just there's friends, you meet people enough. But
Yeah.
they have a very interesting HFT targeted that's I think supposed to be, or they're trying to be faster, or
Hmm.
even a competitor to the solar flare cards.
Got it.
I
Okay.
don't know if they support White Rabbit. They may have implemented it, But
Mm.
again,
Okay.
to me, if you get it right with just coax, I mean, it should be pretty
Yeah,
good.
it should be pretty good. Yeah, no, totally. I agree with you.
Yeah.
And that actually will be better than using White Rabbit or PDP. So I think that should be good. Yeah.
I'm not they'll take offense to that. I'm not touching that. I like simple, you know.
Yeah, me too, definitely. Now that you've shown me the what you have, so I'm
Yep.
actually now more worried about, or thinking about, the actual the solar flare cards. Have you ever used them? How are you going to test them? Do you have the setup available for them to test the AI workloads? How's your plan
Yeah,
for
so
that?
that's the other thing I was going to show you. Just give me
Okay,
a sec. I'm going to switch my headset to
sure.
Bluetooth.
And sorry if it's going overtime, please let me know. I'm happy to stop and we can continue in the next follow-up meeting. Yeah.
Hold on, I can't hear you right now.
Oh, let me know when you can hear me. Yeah, let me know. I am not able to hear you, David.
Give me a second. Okay, can you hear me now?
Yeah, I can hear you now.
Okay,
Okay,
perfect.
perfect.
Where I would put this, some combination probably in here. So
Okay.
this is one of the two racks that makes up the FinTech lab. Can't really see it from that angle. Sec.
Sorry, you
But
have to move.
I'm set up to do exactly this demo because I do it for. This is a different rack of computers, but some of the ones we could use in here, for I'm on for these purposes. Down at the bottom, I have two of the AMD Super Micro very fast machines. These are designed
Okay.
exactly for things like trading.
Hmm.
Then also in the center, you have this massive AMD box. This is designed for doing like AI and deep learning. Now, I don't have
Oh, perfect.
GPUs in it right now, but it is so many CPU cores, we could also do it that way.
Mm.
But that'd be perfect for that. And then the others that I have a big array of, we'll see if the cable gods. Just take my word for it. I don't feel like running the cable. I think things will get torn out. I have five of these older generation super micro machines that at
Okay.
the time they were released about 10, 12 years ago, I think they were the
Hmm.
fastest stack benchmarked solar flare Intel Xeon.
Hmm.
Like,
Okay.
and three of those are set up that I could put solar flare cards in them. I think all three already do have a mix of different solar flare cards, some combination of the 7 series, the 8 series, the X2, the X3s.
Got it. Got it.
I plan
Okay.
on taking all those and racking them into that rack behind me. It's one of the things on the to-do list, but it's lower priority right now. But for something like this, I'm happy to do it.
Okay. Perfect. I guess you already have, David, everything. And that's what it seems like. So,
Yeah, that's why I volunteered because like what you guys are
yeah.
describing is something that's already been on my to-do list anyway, a bunch of ways,
Yeah.
and
Hmm.
then put students on it to be like, okay, now try this setting, try this,
Yeah.
compare pulse per second to PDP, compare PDP in different modes, and how does
Hmm.
it change as a function of packet load, stuff like that.
Okay. So that brings me to one quick last question. I mean, for today, I mean, and then we can continue tomorrow, later. I mean, um, what is, so it seems like you have all the setup you need. You have the PDP time signals, everything. You have the servers to run the AI workloads and integrate those solar flare cards. Everything is good. What is, what else is that you need? Like what is pending or what is missing?
Yeah, so the only potential things would be if we wanted to use one or more vendors that are production grade GPS masters instead of
Okay.
sort of like a homebrew one. And
Hmm.
that's if they want to be involved. If they do, it's very easy to set one up. I have, a line of half the sky. I know the chips already work. So if they want to do that, it seems sort of like at least Spectracom or not Spectracom, the Ray and Saffron was interested possibly in that. We could also talk to Timebeat if they want to get involved to see if that
Hmm.
makes any material difference. The one that is interesting that I do not have at all
is I have relatively new AMD chips, three
Hmm.
different types. Those are the F Max 5.8 gigahertz, and I can send you the model numbers. I forgot offhand. And then I have the
Yeah.
Epic Genoa 96 core, but none of those support PTM. Similarly, the
Hmm.
Xeons I have in the other room that are going to go in there, those are Haswell generation. They are way behind. I think it's the sixth gen that has
Hmm.
support for PTM. I don't have any devices at all that do PTM. So if we want to
Hmm.
do that, we can rope in Intel and see if they want to contribute. I'm happy to host those. The only cap is I'd really hope these would be 1U devices. I'm
Hmm.
not looking for any more 3 or 4U. I mean, I could do it, but
Hmm.
space they're a pain to rack, and sometimes honestly they're heavy as hell. I would do all this stuff myself. I'm
Got
literally
it.
the janitor, the network guy, the physical racking guy, and I don't have one of those fancy cranes. I literally
Yeah.
throw it on a standing desk. I'm not joking. That's how I rack it if it's within a certain height range. Um,
Awesome. That is
yeah, but
lovely. Yeah.
yeah,
Hmm.
so but if Intel are interested in getting involved in that as well, but I mean, we could talk to them and see, and then it could also be a mix of different tech. And then the other thing I don't have that I've been trying like hell to get are GPUs that are specifically capable of doing LLMs, right?
Okay.
With for
So that is
AMD.
definitely we need
Yeah,
basically.
so if you want that, that's the one thing that's been driving me nuts that I don't have in the lab. And the reason for that is I have a lot of students doing not just LLM projects, but agentic AI. And so it's
Hmm.
not them manually querying an LLM. They're writing code and agents that are
Hmm.
continuously polling it to generate strategies, generate optimizations, do other
Right.
types of agentic AI projects. And right now, they have to throw down their credit card to get ChatGPT API
Hmm.
tokens.
Right. Right.
That's
Right.
why I keep pushing the vendors to try to get it. And maybe there's more sway if it's part of this effort. Though I've told them there are a lot of different applications we want to use them for. But
Hmm.
that's been the most frustrating pain point is getting some of those. What I do have though that it could for the inference side, which I'm not sure is the primary interest for time sync. That's
Hmm.
more for training, but for the inference side, I do have FPGAs, and you
Hmm.
can compile different neural nets into the gates of them. And so this is
Hmm.
something actually I've been looking at now. This is the AMD Xilinx like Versal line of chips, and there's some other tools as well where you can even like train a model. You have the weights and do it in PyTorch, and then there's a series of conversions you do that you can then load that into the FPGA itself, subject
Hmm.
to keeping the size of the model a certain size. So we could do that as a proxy, but my
Hmm.
guess is the point of this project, and correct me if I'm wrong,
Hmm.
when I first heard about this idea from Dan Biderman, who at the time was at Intel, now he's at a startup, but it was
Hmm.
really more for this idea of when doing the training of these massive GPU clusters, they're
Hmm.
stepping on each other and saturating the network. And so if we could
Correct.
better synchronize up when to hit it, but to
Hmm.
do that, we would really want not just even one inference box, but like an army of them.
Hmm.
The other thing we could look at, but then it goes to a very different tech stack, would be to see if NCSA down in Urbana would be interested. They
Hmm.
do have a non-trivial size cluster.
Hmm.
Um,
Hmm.
I don't know for sure off the Knicks. They may be doing InfiniBand or higher end, and if they are, they may have Mellanox. Mellanox, I think, have supported PDP for a while. I don't know if they have the pulse per second counters.
Hmm.
The only downside there is then we're not dealing with my lab, and I don't know how long it takes to rack things, to connect
Hmm.
things.
Hmm.
But that's really the bigger scale, I think, longer term. But maybe this intermediate would also provide value. But that's up to you and the other members of trying to scope this. What is it we want to accomplish in what order and et cetera. But it's a
Yeah.
very
No.
interesting problem. It's literally the $500 billion problem. Rate.
Absolutely. Yeah, no, no, I totally agree with you. I was thinking this way, and correct me, David, if this makes sense. I was thinking, let's focus on the inferencing side first, and we can focus on training because for training, we will need those GPUs to run LLMs. They are definitely, to do all that. And let's say if we do all the POC or this thing with the inferencing focused approach first, then we
Yep.
can switch to training because training is going to be really tricky and different, and we'll need a lot more participation on that one. So
Yep.
what do you think? And from
Yeah.
inferencing standpoint, I feel like you have everything. So yeah,
Agreed. Like I've already run like some of the voice recognition things like
yeah.
Whisper.
Hmm.
Sometimes even on the very fast, small core count devices, they were pretty good at being able to do that. So,
Hmm.
in a case like that, then it's just tell me what sort of workflow you want. We can set it up, do isolated
Okay.
VLANs. Then it'd be
Okay.
the other thing I didn't mention that's also useful. I also have in there the Arista 7150, which is a 10 gig
Oh
switch.
yeah.
This is a very important switch because it's the first
Mm.
one in addition to PDP support. It allows you to get very
Right.
accurate timestamps and feed it all into a capture port. And
Right.
so
Right.
then we can also use
Yeah.
that as like a sixth system of how do I get all the data and know to the
Hmm.
nanosecond on the wire when are these packets actually coming in and going out.
Absolutely. Yeah. I mean, we do have a lot of 7150s and Equinix here. I'm pretty familiar with those
Big fan.
boxes.
Big fan. I
Yeah.
don't have the fancier ones with the FPGAs that are down
Yeah.
to what is it, 18 picoseconds or whatever it is they
Yeah.
quote. But phase one, this would be good. But I have been meaning to reach out to them to actually get some of those switches because I am starting to spin up literally like a custom hardware lab again among the set of projects, but doing a lot more with like FPGAs and custom NICs. And we're doing it already with the PCIe form factor. But getting one of those
Mhm.
switches, I think would be useful as long as it's not too loud because I sit right next to this stuff. So that's always a concern as well.
Yeah. Awesome. No, this is great. Awesome. I think this is all good, David, like we discussed. So let's start with the inferencing thing. I'll take all this information, what you provided. I'll try to put some more details into that document, which I've already uploaded on share drive. And
Excellent.
then I think then let's get started with the inferencing focused. And then meanwhile, we'll start talking to, maybe NVIDIA or maybe Broadcom to see if they can give us those GPUs to run the LLMs for training use case testing. Yeah.
Great.
Cool. This will be awesome. Sounds good. So yeah, I think let's also check with Ramki if Ramki or like I mean Safran is interested in testing their production grade GPS devices or GPS I mean GM Grandmasters. I mean we can talk to them, but I guess you have everything. I think as long as that is working and this accurate, I think we should be good. So
Yeah,
yeah,
and that's the advantage of the pulse per second is if you get it
yeah,
right, you don't need the other massive ecosystem around it. You
Mhm.
really just need that and then a repeater.
Yeah,
And depending on the use case, you don't even necessarily care as much about, well, the Rubidium clock is nice. That helps smooth it out, assuming it's working correctly. The
yeah.
other problem is a lot of this gear, I'll be honest, I bought out of pocket off eBay. So there is
Okay,
that caveat of like, I don't have a, 50 or $100,000 atomic clock, like a cesium reference to compare it against.
okay.
So there is a little bit of hope and a prayer there that, okay, it does what it's supposed to, but I want to be upfront about that. This is,
Yeah, yeah, no, absolutely. I think we might be able to get some of those devices to help you compare those things. I guess what the way I see it going is, companies like Safran and Nvidia and all, they would be happy to help, but they would want to see how we are, they would want to see what is our test bed, like, basic like inferencing setup. And if we can do with whatever you have right now, then they would be interested in more. Once we show them some initial results, they will say, yes,
exactly.
let's
Yep.
let's do it with our production grade devices. So that's what I'm thinking we should do. And I'm really, here to I know you're the perfect person to run this experiment in your lab. You have a perfect lab, honestly. I'm
When
there
you
to help
describe
you.
what you wanted, I was
Yeah,
just hilarious because like I literally built out for exactly this sort of thing.
yeah.
It's just a slightly different use case of pack it in, everyone trades, and just
Right, right, right. So
perfect.
yeah, I think let's do it. I'm there to support you, and I would love to, sometime like come to Chicago and help
Yeah,
and
welcome
visit
anytime.
the lab. Yeah. So okay, perfect. So I'll send out I'll collect all process all these details you showed me, and then I'll put some plan together for inferencing first, and then we'll do some side hustles for training as well. So yeah, I
Perfect.
think all good. And then we'll continue working on this project and we'll have that bi-weekly checkpoint. And meanwhile, that's bi-weekly checkpoint is only for stakeholders to look into it. But you and I, we can connect and do things whenever and anytime. Let me know. I'll be happy to jump on a call and we can discuss things.
Great. Yeah, I'm really excited for this. This is one of the things I built out some of that infrastructure for doing exactly. And then
Yeah,
in addition to stuff I mentioned, like with the 7150, I separately also do have a bunch of passive taps so that I can
yeah.
also passive tap in that way. So there's a lot of different options for this. But yeah, I mean, it's directly of interest. It's something I've even thought of turning into literally a homework or lab assignment for the class because it's a rite of
Yeah,
passage. Set up a DPH
absolutely.
around that, or set up PDPD or SFPDPD. Look at the SF stats log. How many
Yeah.
nanoseconds are you off? Adjust for cable lengths. All the regular stuff.
Right,
So
right. And trust me, nobody's nobody is really focusing on this outside. No, no, I haven't heard of any industry or companies or anyone, any lab trying to, you know, figure this thing out. So we probably could be the first ones. And
It's
yeah,
very
and
exciting.
yeah, and I'm looking forward to, we can also, like, once the POC goes successful, we can publish a paper also, and we can do that.
That'd be great. And then another thing I'd be curious to do that it's
Yeah.
very strongly related to this. It's the distribution of time sync between data centers. So I know Equinix, you have what I typically just call CERMAC, 350 East CERMAC in downtown Chicago.
Mhm.
Do you guys have another presence in Aurora where CME is, or is that 100% Cirrus One?
Let's see. You're talking about the location, right?
Exactly.
Yeah, let's see where we are. I
I was
am
just
not
looking at
very.
satellite photos, and I see there's yet another building next door, but I don't know who owns that. And is that Google Cloud or something else?
Yeah, give me 1 second. Let's see. I mean, I'm not, like, familiar with the
No, I'm
in
on the same boat.
Chicago.
I memorized the trading ones, but I know Equinix has a much bigger footprint than that. Okay, so the
This,
closest you have is CH7, which is in Westmont. And
yeah.
just given the location, I'm guessing that is meant to be the one that's closest. Okay, can you just tell me the address offhand of that? I'm just trying to
Oh,
figure out
yeah.
how close that is to.
CH7, right? Let me see. I should be able to find data centers CH7. Yeah, it's this one. Oh, let me send you on Zoom chat.
111, is that Plaza or Piazza Drive?
Plaza Drive.
Plaza Drive, Westmont. Okay, what do we got? You can see this, and I'm even looking at this on the HFT tracker website, so I can then see what the footprint is. All right, where is this relative to? Just needs to render the links. And where's that relative to Fermi? Okay, so that's about it's about half the distance to CME. So that
Hmm.
would still be interesting. Another thing would be if you have access to those two data centers, and if they
Hmm.
already have GPS, and there's dark fiber. Another interesting project that's very relevant for our industry is how tightly you can sync between different data centers that
Hmm.
are close enough that they have similar sky view.
Yeah, no, absolutely. Actually, when we launched the Equinix own time as a service thing,
Yes.
we don't have a time. So we picked 11 locations globally. So let me, if I go here, so in
Yep.
US we have Silicon Valley, New York, um, and yeah, in US we only have these two locations where we have the timing infrastructure, like, the grandmasters and clocks and everything. And but
Yep.
rest of the locations we are using our Equinix network basically to send P2P and NTP traffic. So in
Gotcha.
Chicago we don't have the time infrastructure, but definitely this one is, let's go back. Yeah, so I think the closest one with the time infrastructure will be New York and Silicon Valley. So
Yep.
Chicago doesn't have a Equinix time infrastructure.
But I could take my gear. So I have four of those EVK F9Ts. If you can give me a rack, or I don't need a full rack, just space on it to put some of this in those two data centers, this would be worthwhile for several reasons. One is an academic experiment. Another one that is of concern is more like national security. Even if you're not using it yourselves, you want to be monitoring the GPS space because I assume you definitely do have customers that are doing this. And so this is one of the reasons I've been having students build these GPS grandmasters. It's actually as a sensor network to detect if anything wrong is happening, ideally in real time.
Got it, got it. One other question, David. Are you only looking for Chicago, or are you good with Ashburn or New York or those other locations on the east?
Longer term, I would want to roll this out to, and maybe we can get a government grant to do it, or if Equinix wants to fund it, I don't think it'd be that expensive. But
Hmm.
just have anything that is a financial data center, and therefore its damage to the U.S. economy is substantially higher. We would want to be monitoring.
Okay. Yeah, no, the reason I was asking is basically Saffron has a few locations on the East Coast. I need to check
Yep.
whether it's Ashburn or New York, but they are, like, I was talking to Ramki about this, and he said, like, if required, he would be able to. provide you a space in Safran's own lab or a cage in our data center.
Yep.
So yeah, let me check with Equinix first if we can get you space in Chicago, maybe like in these one of these two data centers, which
Yep.
you would be interested in what, CH124 or like a long distance ones?
It would be literally two of them. So CH7 is the closest to CME. It would be
Hmm.
that one, and definitely whichever one is 350 East Cermak.
350 Cermak is 1, 2, or 4, one of these three. Okay.
Yeah, I'm not. It's one of them. I forget which one. I know they keep expanding, but my guess is it's CH1 because it's like the original definitive. That's
Original,
where
yeah.
CME used to be out of too. So
Hmm.
in those, but we'd have to see how far apart they are. But it makes sense to have sensoring, and these
Hmm.
devices are not that expensive. You're talking a few $100s for the GPS receiver, and you could do it for
Hmm.
like less than 100 on the Raspberry Pi. And then you're
Right, right.
just uploading the data continuously as like an IoT sort of model and making sure there's nothing weird going on. But if there is, just send out a message to your customers so they know to check it. Because the
Okay.
fundamental problem is we use these clocks to basically measure the heartbeat of the global financial system. So imagine you're a doctor and you're relying on some device to tell you what is the heart rate of the patient. But if you can massively speed up or slow down the clock, you take someone who may be beating at 60, 60 beats a minute, and suddenly you bring it down to like 0.01, they look dead. Or you bring it up, by a factor of four, suddenly it looks
Hmm.
like they're about to crash and their heart's pumping, 5x the normal. So
Yeah.
that's the concern that this could be used to manipulate things and just to give people a heads up. And sometimes it's not even malfeasance. It could be someone has some electronics that weren't designed properly that emits interfering radiation. I have this problem with the key fob on my car. I park in a certain parking lot down the street. It
Hmm.
doesn't work. And often it's
Got it.
just like a neon sign with a transformer or someone's doing something they don't realize. But getting that visibility, I think, is important, and it's something I
Hmm.
think Equinox probably want. And someday, just make it a best practice. If you have any customers running GPS antennas set up like a sub $1,000 thing, we can even open source it, make it like a spin off of the time card. But it's not really for getting time; it's just making sure that no one's doing anything weird at the RF level.
Mm-hmm. Okay. So basically what you're looking for is, so one clarification question, David. Equinix, can offer spaces to any customer who want to, whatever they want to do. I mean, that's totally up to the customer. And we can
Yep.
provide GPS services also. My question is, would you be looking Equinix to like as a provider, like, would you want to be as a customer to Equinix, or this is more like an academic support you're looking from Equinix side?
This is just academic of
Okay.
either Equinix should be doing this and or someone under the Department of Homeland Security or DoD.
Okay.
We should be monitoring the basics of very sensitive infrastructure.
Okay. 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 Yeah. So let me check with with the Equinix. We call them global solution architects and technical team. I will reach
Yep.
out to them and let me chat with them. Yeah,
Okay.
I'll be happy to push this forward and see if, how. I mean, I don't know how they do the academic integrations or but collaborations, but let me check and get back to you.
Okay. So yeah,
Yeah.
maybe something around that. And the other one I'd reach out to is if you have like a CISO or a dedicated SecOps team, chat with them about this sort of scenario and just say, like, even if we're not using it directly, our customers are, some of
Hmm.
these customers control the value of the US stock market. And
Hmm.
so if
Hmm,
they
hmm.
get this data wrong, that could be very bad. And even if
Yeah.
it's not directly your systems, it's not PR you want, and it's very easy, relatively easy to potentially protect against.
Yeah, 100%, definitely. Yeah, I can. We do have a CISO, like, definitely. We
Perfect.
actually we actually recently hired him. So yeah, we're
And just to
changing
set the
organization.
context, like I'll show you because I literally have one sitting on my desk. Does this recording have to be posted or?
No, no, this is only like internal until we
Oh,
post it
good.
externally.
Okay,
Yeah.
okay. So this is like a Lime SDR software defined radio. Sorry, the
Okay.
background's some.
Oh no, I can
But,
see it
but
definitely.
basically,
Yeah.
it's an FPGA with ADCs and DACs. You can get these for a few $100s, and then you can
Mm-hmm.
download a fully open source GUI and just
Hmm.
plug in the values. And I want to pretend to be at this location at this time. It
Yeah.
generates the raw waveforms, and you just click replay. Like this,
Got
this
it.
is not
Okay.
nation state level stuff. They very well do this as well, but we're
Yeah.
talking something like a 13-year-old could do.
Got it. Got it. Oh
And
wow.
that's really
This
the
is
yeah. this is why I focus on this so much because it's so concerning. And I've dealt with all sorts of issues with dealing with the basis of our industry is
Mhm.
essentially, in one sentence, time series analysis.
Got it.
Time series analysis is very difficult if you can't trust the time.
Yeah,
So we spend an
100%.
enormous amount of time going down the rabbit hole of like, okay, how does this device work? Oh, it's using this chip. How does this chip work? Oh, it's using this waveform. Oh, let me
Yeah.
capture this raw and figure exactly how everything's working and what are all the edge cases that break this so I can make sure that doesn't happen in production.
Right, right,
So,
right. I agree, definitely. Yeah, no, this is interesting. I'll check on that and get back to you definitely. And yeah, I think one last thing before we close, so
yes,
the reason for the inferencing use case that we are trying to do, and I think you just brought up that pretty good point, like time analysis is
yes,
not possible without good time. So
yep,
same thing, like for inferencing, we really want to see the time stamping associated and the sequencing of the tokens, basically. That's where we want to focus, like how does this time sync issues can affect the token flow. That is the main goal what we want to actually see. So
100%.
yeah, so okay, so I think this is all good. Anything else, David, before? And I'll send you a summary of today's discussion. Of course, this Zoom discussion remains confidential until we share it
Okay, good.
publicly.
Yeah,
And
it's just when I start talking about things that could bring down the global financial system, I'd rather that not ever go in the public domain.
no, absolutely. Yeah, these open, I think these OCP calls, they are by default recorded. I don't know how they have set it up,
Yeah.
but this is
I
weird.
don't mind.
Yeah.
Yeah, as soon as I log in, it says it. I don't worry about that. It's just, but
Yeah.
it's these certain sorts of things. And related to your last point, then I've switched to another
Yeah.
call, but this is
Yeah.
another area I'm very interested in. And so another one of the ideas, this is one of the reasons I have students building FPGA custom network
Mm.
cards is another way to fix this is you add more buffering in the network or have like a
Yeah.
dedicated buffer in clients. And
Mm.
so like I have some very high-end FPGAs, they have tens of gigabytes of RAM on them and they have
Mm.
four 800 or four 200 gig ports. And I could
Mm.
add even more by the back. So you could
Mm.
have this hoovering up all the data and
Mm.
then one intelligently hold on to it
Mm.
and then get the signal, let it go. But two, instead of relying on the host to try to do replaying, relying on these devices. And you could even look at where in the network should we be placing these, for example.
Right, right. Oh, yeah. That's a good idea, definitely. Yeah.
And it's not the standard model of typically it's like either the hosts or the
Yeah.
switch devices, but neither of them are really, at least were originally intended to do this. And the other thing it allows you to do is you can figure out your choke points and then
Mm-hmm.
put them where you need that extra storage capacity. And once we start getting more real world data, we can
Yeah.
get a better sense of what data sizes of bursts are we talking about? Is this
Right.
really just a series of microbursts, but we're really talking about a few hundred megabytes or a few gigabytes? Or do
Mm-hmm.
we actually need terabytes of storage? Even if we need that, though, one of the
Mm.
other things that very interesting in these devices is on the back, they have these connectors that are basically you can do PCIe. And so
Mm-hmm.
not only can you use RAM, you could also hook up something like dozens of NVMe drives with
Mm-hmm.
tens of terabytes of storage and be having
Mm-hmm.
a custom almost like RAID controller
Mm-hmm.
striping these network data directly to these NVMEs as a buffer and then pull
Mm-hmm.
the data.
Got it. Got it. Okay. Yeah, that's a good idea, definitely. Yeah. I mean, that would be another approach that can be used, definitely.
And
Yeah.
it's an easier one because then you don't have to go in and mess with the details as much of the
Yeah.
existing flow. It's really
Right.
almost an equivalent like body armor or something, an additional buffer. So
Right. 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 Awesome. Yeah. Cool. Sounds good. Thanks, David. I know you have to jump to another call, but let's meet on December 5th for the follow-up meeting. Yeah. Thank you.
all
I'll
right,
say
that
keep you posted in between. Thank you.
sounds good. Looking forward to it. Have a great day.
Yeah. You too. Thank you. Bye.